I'm Joby and welcome to a Node 7 electronics video. This is the second part in our KiCAD basics series, and last episode we left off with this fully finished sort of schematic here, and in this one we're going to begin doing PCB design. So the first thing that you're going to need to do is go click this net button and generate Netlist. So click generate, it'll automatically put it in your project directory, click save, and there you go. Then you're going to go over to this run CVPCB to associate components and footprints. Click this. Now you'll see that it'll open up this window here. Now, when it first runs, it'll look like this with nothing showing. And to fill in these fields, what you're going to need to do is select the part. So we'll start with the AT-Tiny, for example. And you're going to use these three sorting buttons up here to help find your part. So in this one, this is a 20 pin part, so we're going to sort by number of pins, and there we go, dual inline package 20. So just double click that and it'll fill that out. Now some of them, there's a lot more parts that have that many pins. So what we're going to do is we're going to find the, for example for this one, we're going to find the pin header library and click sort by library. Now it's sorting by number of pins and library. So the only 2-pin part in the pin header library are these ones. So we're just going to go straight 1 by 2. And same for this one. Same for this one. And then we're just going to go through and fill this in using the same sorting techniques. For some of them you can use this button here, filter footprint list by keywords. So by clicking that, you can see that it just brings up all of the LEDs that'll work for us. You're just going to have to go through and find all the parts that work, again using these 3 sorting tools to find stuff that's right for you. So I'll get back to you when we're done. Alright, once you've filled out all of this, then what we're going to do is just click the save button right here. That'll save it, and then we can close out of this window. Click the netlist once more, click generate, again save, and now we're ready to begin designing the PCB. So we're going to go to the PCB program, which is the second one in from the right. Click that, and it's just going to ask you, because no PCB has been created for this project yet, if you'd like to create one. Click yes, and then we're going to click the net button, read current netlist. Here we've got some errors, and these are saying that for the U1 part, pad VO is not found in the footprint. So we are going to fix that right now. So we can close out of there, close out of there, exit without save. Then you're going to go over to your schematic, click library editor, and then you're going to select the working library. We're working for the 7805, so regulator, and then select your working component, select the 7805, and then you're going to go over the VI, hit edit, and change the pin number from VI to 1, and go through for ground to 2, and VO to 3. And to edit you press E. Now the reason that was happening was because in this schematic component, this pin is labeled as VI, but in the actual footprint for the PCB, it's labeled as 1. So we need to change these associations. So once we've made that change and we've made sure that we've saved, we can close out of the library editor, and we can generate a netlist once more. So click netlist, generate, save, open the PCB program, yes, netlist, read current netlist, and then no errors as you can see. So we can just close out of this window. Now we're ready to start actually designing the PCB. To start off, we're going to spread everything out because you can see it's all clumped around its center here. So using M on our keyboard, we're just going to start spreading everything out. I'll get back to you when I'm done with this. Alright, there we go. Now everything's spread out roughly. Now as you can see, all of these white lines are the connections that need to be made with actual traces on the circuit board. So we're going to start by moving all the parts closer to where their final positions will be. Using M and then pressing R on our keyboard to rotate things. What we're trying to do is get things so that there's as little overlap as possible. So this wouldn't be good because all of these traces cross over each other. This is better. So we're just going to start positioning things in the position that closer to the position that they'll be in the final circuit. And just something to keep in mind, some things need to be placed in specific places for reasons. Like crystals, it's best to put them close to the microcontroller. So just keep that in mind when you're laying out your parts. So again, I'll get back to you when I'm done laying this out. Alright, now we got everything roughly laid out. My main concern was with this long one and everything directly interfacing with the microcontroller. So first let's start with the crystal and actually laying down traces. So what we're going to do is click this Add Tracks and Vias button right here. Something we're going to want to check first is design rules. Now, global design rules and this. So I know that the board house that I want to use to manufacture this board, I know that their minimum track width is 6 thou, and I know that the track clearance is also 6 thou. So we're just going to change that right now. There we go. And now we're going to go over to here and we're going to create some various different size track. So we'll create one that's 10 mil, we'll create one that's 20, let's go 25, and let's go 50 mil for a really big trace. Click. Now that's good. Now we're also going to change up this via a little bit. The via, we're going to change this to 25 thou, and we're going to change this to 16 thou. There we go. Now these you can change once you get a feel for them, but for now we're just going to leave it like that. Now, using this Add Tracks and Vias button, we're just going to begin drawing. Make sure we're on the front copper and begin drawing. Actually, let's make the trace a little bit bigger. That's okay. So now we're just going to begin connecting up these by clicking on one pad, going over to the next, and just going through. And what we're trying to do is all of these white lines connecting everything up right now. We're trying to get rid of those by replacing them with actual traces. Down here, it says unconnected. By the end of this, this should say 0. So, we'll continue going, connecting everything up. Let's move this up using M. Bigger. So we're just going to go through and connect everything up. Now in a situation like this, it'd be nice just to be able to drop this down, but as you can see that there's this trace in the way and we can't have those overlap or else that'll be a short circuit. So what we're going to do is press V on our keyboard, B, and that's going to switch us to the back copper so we can continue drawing these traces. And you can go right over this because they're on opposite sides of the circuit board. If I open the 3D viewer, this is right here. This pad is connected to this one, but as you can see, there's no trace going on this side. If I spin it around, you can see there's a trace on the other side. So it's okay to overlap red and green. Sometimes, though, you need to switch between the top and bottom copper multiple times in one route. So what you're going to do is begin drawing a wire, and then press V, and that'll put in a via and also switch the side for you. And you can continue drawing, and let's say you want to switch it again, press V, and there we go. So if we look on the 3D view again, it starts on this side, goes through this little hole, comes around through this little hole, and onto this side. So again, to do that, you press V on your keyboard. We're going to undo that because that's not the best way to draw that line. And we'll just draw another line here. And now you're just going to basically position components in the best way, making sure that the fine outline around this trace and the fine outline around those pads, you want to make sure that those never touch. If this trace is too close to this pad, even though there's a little bit of a gap, when the board is being manufactured, small defects may cause there to be some extra copper there, which may cause a short circuit, which you of course never want. So we're just gonna work through, make sure we leave adequate clearance for everything. And I'll get back to you when this is mostly done. Alright, everything is looking about good now. So what I'm going to do at this stage is click the add graphic line or polygon and switch it to edge cuts. What we're doing is defining the edge of the board now. So let's go about there, and we're just going to trace it around the board. Don't worry if silk screen sticks out at the moment, that's okay. There we go, so there's our board. If we go to View, 3D Viewer, you can see you get a pretty nice representation of what the board looks like. So that's that. In the third and final video, I'll be showing you how to tidy up your board and make it look good. So anyways, this was a Note 7 Electronics video. Thanks for watching. Please like, comment, and subscribe.